Welcome to the Explainer. Today, we're taking a high-energy deep dive into a piece of hardware that you've probably seen popping up everywhere in the commercial aquaculture and hydroponics world. We're talking about the EcoPlus Air 7 commercial air pump. If you've ever stared at a massive water setup and wondered how they keep the whole thing oxygenated without the equipment just straight up burning out, well, this Explainer is absolutely for you. We're going to break down the pros, the cons, the ideal applications, and even get into some gritty, real-world troubleshooting.
Okay, let's dive into this with a pretty wild question. What happens when your hydroponic system runs out of breath? It sounds like a strange concept, right? But your plant roots literally need to breathe. In deep water culture, or any high-volume aquatic setup, the water itself is essentially acting as the lungs of the entire system. If that water runs out of breath, your plants or your fish will effectively suffocate, and it honestly doesn't matter how perfect your nutrients or lighting might be.
To really understand why heavy-duty hardware is necessary in the first place, we have to look at the science. A recent, comprehensive study out of the University of Georgia looked at leafy greens in hydroponic systems, and they confirmed that dissolved oxygen in the root zone is absolutely crucial. High levels of dissolved oxygen facilitate vital root respiration. This energy generation allows the roots to rapidly increase their water and nutrient uptake. Not only that, but a well-oxygenated environment drastically cuts down on harmful pathogens, which ultimately leads to a massive enhancement in overall plant biomass. In fact, that study showed that optimizing dissolved oxygen could boost arugula biomass by a staggering 191%. No way, right? That's a huge jump.
But, the flip side of that equation is severe. When your dissolved oxygen, or DO, levels drop below 3 to 4 milligrams per liter, disaster strikes. At these critically low levels, root growth is severely inhibited. The roots suffer from hypoxia, leading to dark, browning roots that just can't feed the plant anymore. This is exactly why a flimsy, standard aquarium pump just won't cut it for a serious commercial or large-scale hobbyist setup. You literally need to forcefully inject air into the water 24 hours a day, 7 days a week.
Section 1. Let's meet the EcoPlus Air 7.
So the crucial point is right here with this massive number, 3,566. That is the exact number of gallons per hour that the EcoPlus Air 7 pumps out. To put that into perspective for a second, this single unit is pushing nearly 60 gallons of air into your water every single minute. It's a total commercial-grade beast, designed specifically to handle incredibly high-demand environments.
And honestly, you can see why it pushes so much air just by looking at it. It physically looks like a heavy-duty engine block. Notice that rugged commercial exterior and the sturdy built-in handle on top. At over 14 pounds, you aren't just going to toss this in a drawer. It's meant to sit firmly in place and run continuously without vibrating off the table. Now, what's really interesting about this slide is how it outlasts those cheaper pumps. Instead of a simple rubber diaphragm that wears out super quickly, the EcoPlus Air 7 is driven by a powerful electromagnetic motor. When AC power energizes the internal coils, it generates a magnetic force that pulls on a pressure spring. This creates a straight-line reciprocal motion, so the piston moves rapidly back and forth, changing the volume of the cylinder and automatically opening and shutting the valves to intake, compress, and forcefully discharge the air.
Because of this demanding mechanical process, the internal specs have to be top-notch. It utilizes an SF new type wear-resistant material for both the cylinder and the piston, all housed in a ZL102 aluminum alloy case. But perhaps the most important spec on this list for growers and fish keepers is the oil-free lubricated design. This is huge because it ensures that the compressed air being forcefully pumped into your delicate water reservoir remains completely purified without any risk of oil contamination harming your plants or livestock.
Section 2. Let's talk about recommended applications.
You wouldn't use a sledgehammer to drive a thumbtack, right? Well, you wouldn't use the Air 7 for a single goldfish bowl either. This pump is widely recommended for serious deep-water culture hydroponic systems, massive aquariums, and commercial fish farms. Out of the box, it comes with a heavy-duty chrome air manifold that splits the single output into 6 to 12 different air outlets. So it's absolutely perfect for splitting air across multiple tanks, running massive air curtains, or powering a dozen large air stones simultaneously.
Let's move to and see how this builds a realistic picture of what owning this machine is actually like. We have to look at the objective teeter-totter of its strengths and weaknesses. On the pro side, you've got purified air, excellent heat dissipation, and that massive output. But on the con side, we're dealing with a heavy footprint, high energy costs, and some very specific maintenance quirks that owners absolutely need to be aware of.
Section 3. The pros.
built to last. Look, if you run an electromagnet back and forth thousands of times a minute, it generates heat, a lot of heat. The EcoPlus Air 7 combats this by using that high-quality aluminum alloy case wrapped in deep radiation fins. These fins drastically increase the surface area of the pump, providing highly effective heat dissipation. This allows the whole unit to maintain a constant temperature and pressure operation. Because it's constructed from these premium materials, it's not going to just overheat and melt down on you, even when you're running it 24 hours a day, 7 days a week.
Section 4. The cons. Maintenance quirks.
The very first drawback we have to talk about is the power draw. The EcoPlus Air 7 draws 200 watts of electricity. Now, in the context of that University of Georgia horticultural study we talked about earlier, researchers noted that running heavy-duty aeration equipment can incur energy costs over 140% higher than simpler setups. Pulling 200 watts continuously for weeks or months on end, that will significantly drive up your overall energy bill. So you really have to ensure your crop yield justifies that operational cost.
Then there's the reality of maintenance and replacement parts. Over on the Overgrow hydroponic forums, a grower going by the name Lightear shared a very real frustration. They noted that their pumps had busted, and it appeared the manufacturer had discontinued the specific diaphragm replacement parts. Finding the exact manufacturer-approved parts for these pumps can sometimes be a massive headache, leaving growers to rely on generic parts or some clever DIY engineering.
And that brings us to this incredibly gritty, real-world troubleshooting step shared by that same forum user. If the pump stops pushing air, the issue is often that the magnets on the assembly aren't getting a strong enough pull from the motor's electromagnet to vibrate back and forth. So what's the DIY fix? You unplug the unit, open the front casing, and slide the assembly out. Then, using pliers, carefully bend the metal levers holding the magnets so they sit physically closer to the motor's electromagnet. It takes some trial and error to get the angles just right, but once those magnets are closer, the pump catches the magnetic field again and works perfectly. It's a very hands-on fix for a heavy-duty machine.
And this brilliantly illustrates why there's a vital safety rule from the instruction manual that you just cannot ignore. Because of that open motor casing, you must place this pump above the water level or use a check valve. If the power cuts out, gravity will cause the water from your tank to siphon backward through the airline tubing directly into the pump. If water gets inside that aluminum casing and hits the electromagnetic motor, the pump is totally ruined, and you risk a serious electrical shock. Always, always protect against backflow.
Section 5. The final verdict.
When we lay out the raw specs, the story is pretty clear. You are getting an astonishing 3,566 gallons per hour of output at almost 7 psi pressure. That is literally enough to bubble a small pond. But the trade-offs are right there next to it. It consumes 200 watts of continuous power and weighs in at a hefty 14.1 pounds. You're basically trading energy efficiency and a lightweight footprint for raw, commercial-level oxygenation and aluminum-clad durability.
So, I want to leave you with this final thought. Is this commercial power actually worth it for you? If you're running a massive, multi-reservoir deep-water culture system where peak dissolved oxygen dictates your profit margins, then absolutely. But if you have a smaller, more modest setup, you have to carefully weigh if that 200-watt energy cost and the potential for hands-on DIY maintenance truly fits your needs. Thank you so much for hanging out with me on this deep dive. I hope this explainer gave you exactly what you needed to know to keep your water breathing.